guys, welcome back to another video lesson. Today we are talking about power theorems. So previously we have talked about angles and arcs inside of circles, and today we are going to be talking more about the segments inside circles or around circles. So pause the video right now, please, and read about the chord power theorem. All right, so you have taken a minute. I don't know why this won't go away. There we go. Okay, so you've taken a minute to read about these, and you really, all that you are doing is multiplying going down the chords. Okay, so given AC is 14, BD is 18, so the entire length here, let me see here, I'm given this entire length as 14. So that's 14. And then I am given this entire length over here as BD is 18. Okay. And then EC is 9. So just this portion over here is 9, which from that, since the entire segment is 14, if just EC is 9, then I know that AE must be 14 minus 9, which is 5. And what I'm going to do for this other one here is I am looking for DE. So I'm going to call DE X. And then I know that the entire length of BD is 18. So to determine just the length of BE, I'm going to take 18 minus X, which is just like what I did to determine that 5. Okay. So now to solve for X, I need to just multiply down the segments. So I have 5 times 9. Multiplying down AC, right? So AE is 5, EC is 9, multiply down the segment. So 5 times 9 has to be equal to X times 18 minus X. Okay, so not so bad, just setting it up. Now, all that I need to do is solve this algebraically. 5 times 9 is 45, is equal to 18x minus x squared, just distributing in that x. So now what I'm going to do is, because it's a quadratic, I need to get everything equal to 0. So I'm going to add the x squared and subtract the 18x, because that'll keep my x squared positive, which for me, when I'm factoring, is just a little bit easier. So adding the x squared to both sides, I get x squared plus, and then I am subtracting 18x from both sides, so minus 18x plus 45 is equal to 0. Now, you can factor this whatever way you want. I'm just looking for two numbers that multiply to 45 and add to negative 18, right? So what multiplies to a positive 45 and adds to a negative 18? Those two numbers are x minus 15 times x minus 3. And that has to equal 0. Okay, so I'm just factoring it. So now if I individually take these, so like x minus 15, take that, set it equal to 0. X is equal to 15, just applying the 0 product property. Or x minus 3 is equal to 0, so x is equal to 3. So I have two answers in this, 15 or 3. And since I set X as DE, that's what I was looking for, those are my two final answers. So those are the two possibilities, and it's kind of because, you know, like you've got one shorter side and one longer part of the segment, and you're just solving for one of them. So you could have solved for the shorter part, or you could have solved for the longer part, depending on it's 15 or 3. All right, so those are your two possibilities. Next, we are going to talk about the tangent secant power theorem. So once again, please pause the video and take a moment to read about the what this theorem is, kind of see what all information we've got here. Once you're done, hit play. Okay, so you've taken a minute to read about this. So what do we have here? The tangent part of your the tangent segment, right? If you take that and you square it, it's equal to the external part of the secant part of the segment times the full length of the secant segment, okay? So all of these theorems can be proven using similar triangles. So if you guys want a fun little quarantine activity, feel free to go through and see if you can find the similar triangles and prove them. If you've got questions, feel free to email me or Mr. Gibbon. So let's start by labeling what we are given here. So AD is equal to 6. And then BC is equal to 9. That entire segment here is equal to 9. And AB is what we are looking for, so I'm going to call that X. All right, so setting up my equation, I know that the tangent part is what I'm going to square. So 6 squared is equal to, then I have to take the external part of the secant, so X, times the entire length of the secant. Well, the entire length of the secant is this entire thing, otherwise known as X plus 9. You just have to add them together. Okay, so now I'm just solving this algebraically. 6 squared is 36 is equal to X squared plus 9X. So in the last example, I added the X squared to both sides when I was getting everything equal to 0, because I always like to have a positive coefficient on my X squared. In this case, X squared is positive as is. So all I'm going to do here is subtract the 36 from both sides. So I get 0 is equal to X squared plus 9X minus 36. Once again, I am in a situation where I am factoring. Okay, so what two numbers multiply to a negative 36 and add to a positive 9x? So I know that I want them both to be, one positive, one negative, because they multiply to a negative. So I am going to say, okay, 0 is equal to X plus 12 times X minus 3. 12 times negative 3 equals negative 36. 12 plus negative 3 equals a positive 9. Those are my two factors. So then once again, I apply the zero product property. X plus 12 is equal to 0. So X is equal to negative 12. X minus 3 could be equal to 0. So X would be equal to 3. So at this point, I notice a problem, and you should too, okay? I don't have actually two possible answers here. Here's the thing. I'm looking for X. X is the length of a line segment. Which of these does not work? The negative 12. I cannot have a negative length for my line segment. So my final answer here must be the positive answer. So in this case, AB is equal to 3 units. Okay, so we've got our length for AB. That's it. In this case, there's only one possible answer. It is 3. All right, so now we are going to repeat. I'm going to ask you to pause, take a moment to read about the secant power theorem. All right. So you've taken a minute, you've got two secants, and basically what you are doing is you are taking the outside part of one secant times the length of the entire secant plus the external part of the other secant times the entire thing. You've got your picture there to help you, and we'll go through an example just so you can see exactly what we're doing. So AE is 3 units long. That's given to me. ED is 7 units long. So, and then I've also got BC is equal to 13 units long. So that's a 13 right there. And I am finding AB, so I'm going to go ahead and call that X. Okay? For this, I know that I am going to need to use the entire side length here of AD. So I can go ahead right away and say that AD is equal to 10. Because 3 plus 7 is also equal to 10. And then I'm going to do the same thing for the other side. I know that this whole side, AC, is going to be useful to me later. So I need to add them together. AC is equal to X plus 13. I just add them together. So setting up my equation, I take the outside part times the entire thing. So for AD, for that secant, the outside part, the external portion of the secant, is 3, and the total length of the secant is 10. So 3 times 10. Now I've got to do the same thing for my other secant. So my external part, this is equal to the external portion of my other secant, so that would be X times the full length of my other secant, which is X plus 13. And now I am just once again going to be doing some basic algebra. 30 is equal to, distributing this in, X squared plus 13x. It's a quadratic, so to solve it, I need it to be equal to 0. And once again, my x squared is positive, so I'm going to keep it positive. I'm going to subtract the 30 from both sides. 0 is equal to x squared plus 13x minus 30. So I need two numbers that multiply to a negative 30 and add to a 13. Right off the bat, you may be thinking to yourself, ooh, 10 and 3. But the problem with that is one number needs to be positive, one number needs to be negative, because they need to multiply to a negative 30. So I've got 0 is equal to, I'm going to use a positive 15, x plus 15, and then a negative 2. Okay, so I factored it. There it is. 15 times negative 2 equals negative 30. 15 plus negative 2 equals 13. I might have just misspoke, sorry. So then, once again, zero product property. Either x plus 15 is equal to 0 and x equals negative 15. Or I could also say x minus 2 equals 0 and x equals 2. Once again, I have spotted a problem. The problem is that I am looking for the length of a line segment, and the length of a line segment cannot be negative. So that eliminates negative 15 as one of our possible answers and gives us x equals 2. Must be our answer. And I did set x equal to AB, which is what we were looking for. So AB is 2 units. All right, so that is it. That's the end of this Vlesson. As a reminder, Mr. Gibbons said in the announcement this week as well, we've been commenting on this, you are going to have your first quiz on Monday. So make sure that you are looking over your notes. Email if you have any questions. As you guys have been working through the video lessons and the homework and everything else that we've had on here. If you notice anything that you're struggling with, make sure to email either Mr. Gibbon or myself, and we will help you out. But that's it for today. Enjoy your extended weekend, and we will see you soon.